Good evening, everyone.
Good morning, ma'am.
I apologize for the delay. It's my weekend morning, so I've been a little lazy.
Yes.
But yeah, I'm here now, so we can get started.
Yeah. Okay. So, thank you so much, guys, for waiting. So, I'm extremely glad to invite the most remarkable woman to speak in our webinar, Miss Anima Patil Sable, an Indian-born software and aerospace engineer. While researching on her amazing work and achievements, I briefly wondered whether I could even fit everything in my little speech. So profound and extensive was her work and dedication towards space. So even when she was young as 7 years old, she wanted to become an astronaut. She completed a BSc Physics from North Maharashtra University, where she also obtained her master's in computer applications. Later in 2000, she moved to San Jose, California, where she completed a master's in aerospace engineering in San Jose University. In 2012, she was offered the job of senior principal software engineer and operations engineer at the KEPLER mission, a position she held for 3.5 years. She has worn many hats. Software engineer in the Intelligent Systems Division at NASA Ames Research Center, commander for NASA's Human Exploration and Research Analog 7 at the Johnson Space Center in Houston, Texas, crew commander of Crew 193 at the Mount Desert Research Station in Utah. Graduated from Folsom Polar Suborbital Science in the Upper Mesosphere Scientist Astronaut Program in 2016. In 2017, she became Citizen Scientist Astronaut Candidate for PHENOM, that is Physiological, Health and Environmental Observations in Microgravity project. She was also the first fire support engineer for high seas. She has also done a Mars analog mission on Hawaii and many more. In 2017, she won the Women of Influence Award. And what is more incredible is that she did all this by multitasking and being a mother of two. She is currently working as Orion Spacecraft Simulations Lab Manager at NASA's Johnson Space Center in Houston. Her humble personality and her yearning to help young students is truly an inspiration to us all. And so today, it's my utmost honor and pleasure to welcome Miss Anima Patil Sable. I welcome you, ma'am.
Thank you, Vanshika. I appreciate it. I appreciate the introduction. Thank you. I'm excited to share my journey, my experiences with you all. So let's dive right into this.
Yes.
Screen sharing present now. Where is present now? There we go. Present window slideshow. Okay. Do you see my slides?
No, ma'am, it's
It shouldn't take this long. Hang on. It's the share. I've clicked the share and
yeah. You'll have an option like entire screen. Did you click on entire screen?
it's just spinning. Wait. Oh, stop.
Yeah, it's visible, ma'am. Ma'am, you're muted, ma'am. Your, yeah, okay.
Okay, I'd forgotten I was on, I rejoined. Every time I join, I have to mute it. Okay, you still see the slides, right?
Yeah, yeah.
Okay. So yeah, I've titled these slides Deep Space Dreams, Making the Impossible Possible for two reasons. First thing is we as humans are trying to do something that's really challenging. Our body is not designed to live and survive in space. Oh, there is an echo. Okay, there we go. That's better. But we are still trying to travel to Moon, Mars. We want to go beyond those to the habitable planets that we've found. And so we're going to try and survive on these inhabitable worlds. We're trying to set up a lunar base as a part of the Artemis program now. And then we're going to go do the same thing on Mars eventually, right? But like I said, the human body has not been designed to survive in the extreme environment of space. Here we've been designed to live in the Earth's protective environment, the atmosphere that we have around us. But on the Moon and Mars, we don't have something similar. So we will die instantly if we don't have a spacesuit, a spacecraft to keep us protected. We're going to die instantly, right? In the vacuum of space, in the extreme radiation that we'll be exposed to. So we are trying to make something that's impossible to live and survive on other planetary bodies as well as our moon. We're trying to do that something which is impossible, and we're trying to make it possible. We're doing a lot of research. We're trying to figure out how can we help astronauts survive on these two places. And that is one of the reasons why I have titled these slides Deep Space Dreams, Making the Impossible Possible. The second reason is I grew up with this dream of wanting to become an astronaut since I was a little girl, but couldn't do much. I got opportunity when I had a 3-year-old and I had a full-time job. So even then I decided to do something about it. It's like it's been a long journey. It's been a journey full of hurdles, but I've come this far. But the thing is, I'm not getting any younger, and still I'm trying to pursue something like this. So I don't know if I'll make it or not, but I want to at least give it a try, and that's how I started this journey. I want to die with the satisfaction that I give it a shot. I tried, I gave it my best. If it works out, fine. Otherwise, I'm at least enjoying the journey. So I'm trying to do something impossible at a later stage in life. I'm trying to make it possible, and that is my deep space dream. And that is another reason why I have titled these slides Deep Space Dreams, Making the Impossible Possible. A little bit about me, and this is a lot about me. This slide is, believe me, old. I have a few more pictures to add to it. But yeah, I'm a very active person. I've been doing a lot of things. Even in school and college, I was like that growing up in India. Very active, extracurricular activities. I have done my bachelor's in physics. So like I said, when I was about 7, that's when we had a book exhibition, and I was always fascinated by stars, and we would be able to see the arm of the Milky Way galaxy in I grew up in my hometown is Jalgaon in Maharashtra, and we would sleep on the terrace in the summers at that time, and that's when I would see that arm of the galaxy and the stars shining bright, and it was always fascinated. And then I saw pictures of astronauts in our school science exhibit where astronauts were laying on their backs and launching into space. And that's when I said, I figured it out at that age that you need to become an astronaut to be able to travel to the stars. I wanted to travel to the stars. So that's how this dream took seed. But then growing up, this was in the 80s. There was no proper way to figure out. We didn't have internet at that time either, right? No social media, no internet. Books were my source of inspiration and knowledge. So, and then Rakesh Sharma ji had launched, he was our first Indian astronaut. So I thought, like him, I'll become a fighter pilot too, because he was a fighter pilot. Pilots, right? We just started doing that recently. I decided I'm still going to try it. Maybe they will like me and they will consider me. So that's how I always have been thinking, that things are not They haven't set conditions. They have conditions that they want only males, but I've always been optimistic that no, things might change by the time I graduate. They might start accepting women as fighter pilots, which did not happen. But even then, I was ready to give it a try. So I did my bachelor's in physics because that was the only degree I could pursue here itself. I'm not going to be able to send you outside. So I did a bachelor's in physics because that was one of the degrees that was mentioned on the Air Force application. I brought the Air Force application. While I was doing that, I would run every morning for miles to make myself stronger. I would join the National Cadet Corps, the N. So I was trying to make myself tough and strong to be able to survive in the Air Force, right? I got the Air Force application. When I was done with my bachelor's, I passed out with a distinction. Even my final year project was based on astronomy. That's how I was interested into all of that. When I got the application, again, the first criteria was you need to be a male. I decided to ignore that and still apply. And then the second criteria was you need to have a perfect 20/20 vision. At that time, I had a small myopia. I was short-sighted, the regular glasses that we all have. Some of us have, not all of us. But yeah, so I couldn't apply then because that condition I could not ignore or I could not waive, right? So I was really disappointed. And I had done all this hard work all my life towards this goal, but I couldn't apply to the Indian Air Force. And so I didn't know that summer was really challenging. It felt like everything was over for me. What am I going to do now? Then my dad suggested there was a master's in computer applications program at our university. The program, there was an entrance exam I had to give. I ended up becoming a software engineer in short. And then I ended up coming to the US. Me and my husband came together here as software engineers. While working here, I was watching the space shuttles launch regularly. We were building the space station at that time. I knew there was a NASA center near me. It was just an hour away from me. So my dream that had dormant, my opportunity. Maybe I should do something about this now. So at that time, like I said, I had a full-time job, a 3-year-old, and then I decided to do a master's in aerospace engineering because I wanted to learn about rockets and airplanes and how they work. Plus, I also knew that having an aerospace engineering degree will take me further towards my goals. And so I did that master's in aerospace. Was a state support from the family. My parents and husband wouldn't understand why I wanted to do this at the age of 30 when I had a nice job, a big house, a kid, right? But I tried to convince them. It was a struggle. They're conscious to your child, to your house. And that's how we think about women, right? They won't be able to balance everything. But through my actions, I showed them, no, I will. You guys are my priority, my home, my family are my second. Work late nights. By the time I finished my master's, I had my second son as well. So you can imagine what I was going through. But why I share this story is that no matter how many challenges, you have to, if you want to do something like this, you really need to work hard, stretch yourself, push your limits, and see how much you can do, right? There is a lot more each of us can do than we give our. So when I had my son, my parents came and they helped me take care of him. That is how I could finish my master's in aerospace engineering. So having your family's support, building a good support system is really important. So you can hurt them and achieve your goals, or you can take them along with you, hurt yourself a little bit, stretch yourself a little bit, and go ahead towards your goals, right? Then your journey becomes smoother. I also recently finished a master's in space studies, human factors. I want to have a varied background. When NASA selects astronauts, it's really, really challenging. This time, 12,000 people have applied. In March, NASA opened up the astronaut application just for a month. After 4 years, they opened the application. And so there are 12,000 people who have applied. There are really highly qualified people who are PhDs, and who have, or if they are not PhDs, they have a lot of educational and work experience, educational background and work experience. So it's challenging. And so having that, how do you set yourself apart from everyone else, right? So everyone tries to do that. And trust me, each of these highly qualified people, out of 12,000 NASA, we learned just yesterday, I posted on my social media, they've narrowed down to 400. And we would have been called in for interview if I have made it into the 400, that is. So they pushed out now. Everything has been pushed out to next summer. They're going to call 150 people only out of those 400 that they've narrowed down for interviews. And they will do their reference checks first, and then they'll call them for interviews next year. So no, if it's a regular time, I mean normal times, these are not normal times for sure. Then by next summer, NASA would announce who they have selected, right? The new astronaut candidate class. But now because of COVID, everything is delayed. And so next year, in next summer, they will actually do the interviews. And so in 2022 is when they will announce. But you can see, despite doing all this, I still don't have a guarantee that if I've made it into that 400 or not. They haven't informed anyone yet. They won't be informing until next year. So all I can do is, even when I don't know yet if I've made it into the 400 or not, I'm still going to keep doing my part, right? I'm trying to finish my private pilot's license. It's been a journey full of hurdles as well. Then I'm trying to get an advanced scuba certification, a lot of things. I have a checklist that I have to complete. So I'm thinking of it, okay, good, this is going to give me some more time. I was disappointed, but I'm going to use this time to continue developing my skills. And that is the reason why I have these 3 master's degrees. It gives me a different background. Hopefully when NASA sees, they'll say, oh, she's a software engineer plus an aerospace engineer, plus she has a space studies human factors degree as well. So that might set me apart, okay, I don't know for sure. So that's how it is. I'm also, I try to keep our India alive by doing a lot of cultural activities during Independence Day. This is the first time I'm not doing anything, otherwise we're performing, celebrating our Independence Day. Then what else? On my birthdays, I challenge myself, I skydive, and then I'm also very actively involved. It's been 11 years now with my boys in their Boy Scouts activities. I'm their assistant scout master now. So I go camping. I help kids, the scouts, with all of their merit badges and all that stuff. So I have a very active life, and that I think is really important. And another thing that's really important is, like I said, I'm not getting younger, but whatever the age, staying fit is important, right? If you want to become an astronaut, you need to stay fit. So I try to exercise, put in a variety of exercise, because one thing kind of gets boring for me immediately. So I run, I try to bike, swim. So staying active is really important. That is how I am a human test subject for NASA's Johnson Space Center here as well, as a volunteer. It's apart from my full-time job. But yeah, I don't drink, I don't smoke. These are important things. And you guys are all so young. This is the time when we get distracted, right? If something doesn't work out our way, we get frustrated. So why I share this is, it's easy to fall into these bad habits, but I always think, is this going to help my body in any way? No. Why should I put junk or trash in my body, right? Smoking, drinking, even drinks. I feel alcoholic drinks. My friends say, hey, Anima, you live in the US and you don't drink. And I'm like, no, it's not a big accomplishment to drink if I'm living in the US. So I have a lot of other things that I do because I live in the US. So don't put junk in your body. Does it add any value to your body? No. And that why I say this is, even as a human test subject, or for the analog missions like Hera that I did in 2015, where I was a commander, for those also, NASA does a thorough medical exam, Air Force Type 3 medical exam, from top to bottom. Your vision, your hearing, everything is checked. Your blood, they make sure, they check what your, are you taking any drugs, or so they basically test you physically. And it's important for me to keep my body free of any as much medication as possible, or any drugs or smoke or alcohol. Moving on, when I started working for NASA on the Kepler mission, that's when I decided I became a speaker for NASA basically. I decided I want to share my experiences, my knowledge with the younger generation because I did not get any guidance growing up, right? So I want to give that to the younger generation. So someone would find inspiration in my story, right? I want to give them the guidance so they could at least achieve their dreams faster, sooner. That's why I've been doing a lot of talks, 12 now. It's been fun interacting with everyone. Some of these are in India. This is at the Computer San Francisco, where now in Maharashtra, where my uncle runs a school for rural and English medium school. Then this is an Ask Me Anything. When I was working on the Kepler mission, we did an Ask Me Anything AMA. This is in Satara in Maharashtra. This is me in a pressurized suit at the University of North Dakota, where I did my third master's. I developed an app for the HoloLens, Microsoft HoloLens, the augmented reality glasses, for astronauts to be able to perform EVA, to use during their EVAs, okay, to help them during their EVAs. My goal is to design an Iron Man helmet, basically, like Iron Man suit helmet. He sees all his vitals and everything in there. So that's what I want to design. So yeah, these are all the things I've been doing. This is just a summary of everything. Let's move on. Right now, what I do, I am the Orion Spacecraft Simulations Lab Manager. I should update that. It's not Simulations Manager, it's the Simulations Lab Manager at NASA's Johnson Space Center. Orion is the spacecraft we are going to send astronauts to the moon and Mars in. And so all that is going to be a fully automated spacecraft, right? It will fly itself. Only when there's an emergency, astronauts can take manual control. But it's been designed to be fully the flight software that's going to fly the spacecraft. I host it in our lab, in our simulations lab. And so all the NASA user community, there might be engineers, there might be people, scientists, they want to test out this spacecraft thoroughly, right? All the flight software, all introduce faults, errors, when it's on its trajectory to the moon, maybe introduce some issue. That these kind of scenarios are what we're going to, they're testing, right? And they're testing it in our lab. So I provide them all the tools that they need. They might need a lot of different test tools or some specific software to run some kind of a different scenario that's not inbuilt into the flight software. So my role is to make this available to them, help them with their, so it's been really exciting being in this role and working on this. I got to learn a lot about the flight software. I software application software background, and so flight software is, so it's working on Kepler, because Kepler's software data processing pipeline was a completely different software, but this one that is going to fly the spacecraft is really different as well. So it's in talk a lot this with you guys. This is my role, but while I'm doing this, I also am a human test subject. Like I mentioned, I'm a voluntary human test subject for NASA JSC, Johnson Space Center. When we are planning to send our astronauts to the moon and Mars now, there are a lot of things we need to test out. How will astronauts, how will their bodies react to something? Or for example, now in this picture where I'm wearing the virtual reality goggles here, right? What I'm seeing in front of me is Mars, is the surface of Mars. Arrive on Mars, right? So when they arrive there, how are they going to get out and start working? Will they be able to do that immediately? Today we see when from the space station, they need some support. They need to be picked up, right? They need support to get out of the spacecraft. They cannot start walking immediately. Why? Because their bodies are not used to the gravity of the Earth. So they've been in space for 6 months. For 1 month or 2 weeks, our body gets, the legs stop working. Used in, they need time to adapt to the gravity. Our muscles get weak, so they need support when they come out of the spacecraft. So you will see astronauts coming back, they are lifted, they're helped. They need some help to get to the place where they need to go after they come back to the Earth's surface. So how will that work on Mars? There will be no one. They've been traveling for 6 to 7 months from Earth to Mars. They arrive there, there'll be no one to help them, to lift them out of their spacecraft, right? So what will happen in that scenario? Do we need to train them? How do we need to train them? And that's what we're testing here. They will be disoriented as well. I'll talk about those physiological challenges in a few minutes. But basically, their muscles will be weak. They will be completely disoriented because they've come from a zero gravity environment and they now have to adapt to a high gravity environment. So there will be a lot of challenges, and we need to understand how we need to train them to adapt to that disoriented high gravity environment again. And that's what we're testing in this. There's an electric pulse being passed behind my ear where the neurovestibular organ is. Oops, sorry about that. And that, why are we doing that? To disorient it. Sorry, I'm like all over the place right now. To make me feel disoriented, basically. That's why they're passing an electrical pulse behind my ear to the neurovestibular feel disoriented. And it does happen. You start feeling disoriented. And then I'm asked to walk with my arms crossed, toe to toe. That's how astronauts train when they come back from space. That's how they train to adjust to the gravity of Earth. But as a part of the human research program for which I'm the test subject. And like I said, we need to have an annual physical exam to be a human test subject, and they make sure if you're healthy, then you get to be there. I get to meet astronauts. I got to meet Sunita Williams ma'am and Josh Cassara, both NASA astronauts. They were training in one of our simulations labs. So I got to meet them, watch them train. It was exciting. This is a picture of the display, an example of a display. Similar display is going to be on the Orion spacecraft. I also got to work as an exploration XEMU, EVA. It's an EVA suit, basically, extravehicular activity suit. It's called extravehicular spacesuit that NASA is building for astronauts to use on the Moon and Mars. I got to work on that last year as well. So these are the kind of things I am working on, and it's really been exciting. KEPLER mission. KEPLER was my first NASA mission that I worked on, and so it's really special to me. I don't know if you guys know a lot about KEPLER, but KEPLER is a school bus-sized telescope which was launched in 2009 to look for Earth-like planets around Sun-like stars in our galaxy, in their habitable zones. Like the Earth is in the habitable zone of our Sun, right? We want to know if there is intelligent life out there. And so we want to do it in a scientific way. We cannot, we hear a lot of stories about aliens. The biggest question is, are there aliens? Is there intelligent life? Are we alone? And that's what the goal has been through. We have Kepler's mission was to look for Earth-like planets. Now, why Earth-like planets? Because our Earth and Sun is a model that we have in front of us, right? Life exists here. This is the planet and star model where life exists. Earth is just at the right distance in the habitable zone from the Sun to have enough heat reach the planet where the water can be in liquid form. Water is the biggest indication of life. If there's water, we will have life, but water needs to be in liquid form. It cannot be in ice form, or if it's closer to the star, it's going to just evaporate, right? So we're looking for something similar. This is what we know. This is a model that works. The Earth and the Sun is a model that works, and that's what the scientists and astronomers decided for Kepler. that we are going to look for an Earth-Sun-like combination to see if there are planets like the Earth out there. In that process, Kepler has found around every star in our galaxy, there is at least one planet. And there are some multiplanetary systems as well, just like our solar system, where there is a star and there are a lot of planets around it. So imagine that, how many stars are there in our galaxy? There are a billion stars or a trillion stars in our galaxy, right? But there are more planets in our galaxy than our stars. That's what we got to confirm with Kepler as well. And then Kepler has found there are a lot of Earth-like planets. They are in their habitable, in their star's habitable zone, but the only thing is they are not a twin of our Earth. Why? Because their star is smaller, cooler, and dimmer than our sun. Our dwarf type of star. These planets that we have found orbiting their star in their habitable zone are orbiting M dwarf type planets. M dwarfs are smaller, cooler, and dimmer than our sun. So the way they interact with their planet is going to be slightly different. The planets will be really close compared to how close our Earth is to the sun. So how an M dwarf interacts with its planet is different than how the sun interacts with its planets, because of the amount of heat and the brightness that that our sun has. So that is the reason why scientists cannot say that it is exactly like the Earth, because they're orbiting a different type of star. But they have found a lot of Earth-like planets in habitable zones of Earth. Now we need to study them further. So Kepler was retired in 2018. It's now more than 95 million miles away from Earth trailing heliocentric orbit, orbiting the sun behind our Earth. But it gave us a lot of good data. And after Kepler, now we've launched something that works as similar to Kepler as possible, but it looks at all the stars. Kepler was just focused on about 200,000, 175,000 to 200,000 stars in the Cygnus and Lyra constellation, just one section of the sky. That was the first of its kind of telescope. So there was a limitation on what we could do with it. But after the experience with Kepler now, NASA launched a similar telescope in 2018. I think it's called the TESS, Transiting Exoplanet Survey Satellite. It works just like Kepler does, but what it does is, rather than focusing in one section of the sky, it looks at all the sky, 360-degree view. It has a lot of cameras, the spectrometers that Kepler had one, it has several of them to be able to study all of the sky. And it is looking at stars that are really closer to us to see if those have habitable zone planets, so that hopefully one day we can travel to them when we have the right propulsion technology. But yeah, that's Kepler. This is how it works when it keeps staring at the star that it's studying. It has a spectrometer on board. So it has a camera, but the camera is a photometer or a spectrometer. It's not similar to our regular camera. It just studies the light coming from the star. So it's measuring the light coming from that star. Why does that keep happening? And when a planet starts crossing in front of the star, the amount of light that Kepler is measuring that's coming from the star is going to dip, because the planet starts crossing. The planet blocks some amount of light. Depending on the size of the planet now, the dip is going to be deeper or shallower, right? If it's a smaller planet, this dip here, it's going to be smaller. If it's a bigger planet, it's going to block more light, and so it's going to be bigger, deeper. So these are the dips. These are called the transits that Kepler is looking at. And these tell us that there are planets around the star. Now there is another whole different set of slides I have where I talk more about Kepler. But yeah, I just thought I will mention it a little bit in these slides. So that's Kepler. Now we've been to the moon. We've built a space station around our planet, a big laboratory while it's orbiting at 7 miles per second. So we've been there, we've done that. Now what's next? Our destinations of the future are Mars, asteroids, moon. Now we're going to the moon with the new administration. We've decided we're going back to the moon. Then Kepler, because it's a favorite mission, I cannot resist putting Kepler planets there, right? These are the habitable zone planets, and NASA has designed some fun posters of these planets. Like I said, I can talk about each of these posters, and it's really interesting, but we'll get really late and I want to move on. But yeah, these are our destinations of the future. Now, I'm a big space movie buff, right? So I've included these fun slides. But what I want to show here is we want to travel to these planets, habitable zone planets, or deeper into space one day. But there are challenges right now. What those challenges are, we don't have a propulsion technology that can help us travel close to the speed of light or faster than the speed of light. And that's what needed if we want to travel to planets around even the closest star, right? 4 light years away. Even then, we will not be able to reach in one human lifetime. So we need, with this technology that we have today, so we need a that's really faster, this is Starship Enterprise, right, from Star Trek. You all know what it is. It runs on the hyperdrive. It travels at the speed of light because it has a hyperdrive. Now, hyperdrive does not exist in reality. It's a fiction. But bottom line, we need some technology like that. We are far from getting such technology to work right now for us. But it's a research area, and if you are interested, you guys can look into it as well. The other thing we need is a suit that is light, flexible enough to help us move around easily on other planets if you're going to travel that far. This is the suit in the Interstellar movie, and then this one is in the Martian. Now, these suits, if you look at them, and if you look at NASA's suits today or whatever we have on the space station, even the Soviet suits, they are really heavy, they're really bulky. The extravehicular activity suits are really heavy. The NASA suit is, the NASA, what is it called? EMU is 250 pounds. It's that heavy. But in space, of course, in zero gravity, you don't feel all of that weight, but it's not really flexible because you can't move really easily in it. There's not enough flexibility. The joints, the area where our joints are, especially astronauts get bruises on their elbows and all wherever there are joints, because we need to design a more flexible suit. This one is really old technology, the one that we are using today on the space station, and that is why NASA is designing the new suit now, the new XEMU. It's going to be more flexible. It's going to give astronauts more flexibility. They are walking on the surface of Moon and Mars. Hopefully it will be a little lighter. We are building in a lot of redundancy in it. We are going to have a lot of battery power in it, because today's suit, it lasts you for 6 to 7 hours, 8 hours at the most. It can't last beyond 8 hours. We have to come back into the space station after 8 hours. That's the limitation, the power limitation, the life limitation on it. But for planetary and lunar surface EVAs, we cannot have that limitation. We need to be able to do those EVAs for longer, right? Because we're on a different moon, or we're on our moon or a different planet. And so we need that longer duration to explore. And that's what we're trying to build in this new suit. A lot of redundancy, more extended battery life, plus the life support system is what actually makes the suit heavy. And this life support system is going to have redundancies in it as well, so that it lasts for that. If our battery is going to last 16 hours, we want the life support system, the oxygen, our oxygen tanks in it, right? We want it to last for that duration as well. So that makes the spacesuit really heavy. And these are biosuits. They're really form-fitting, right? They're really lightweight as well. Why? Because the life support system is really compact on them. How? It's a fiction at the end of the day. So this kind of a system is not possible today because, like I said, life support system, which is on the back, in the backpack, makes the bulk of the suit. So we need a biosuit, and biosuits are a challenge today because of several reasons. You can Google and research on them. But yeah, you can look into, if it interests you, this is a good research area as well. Designing a biosuit will really make the life of astronauts easy when they go to the moon and Mars. And even NASA's new suit is not a biosuit yet, because there are several challenges involved in the design of a biosuit. Okay, so we need a good spacecraft, we need a good suit. These are good areas of research. And then we're going to go to Mars eventually with these technologies. So now this is a slide that shows you why we are talking about going to the moon and not directly to Mars. We've been to the moon, right? A lot of people are questioning, why go back to the moon again? Why not directly go to Mars? Because there are a lot of challenges involved. Mars is about 65 million miles away from us, right? The moon is closer to us. It takes hardly a day or two to get to the moon and come back, right? To go to Mars, it takes us about 6 to 7 months. We haven't tested a lot of technologies, right? Habitats, for example. Then the water process, what do you call that? Water recycling systems, for example. We will need all these when we go to the moon and Mars, to Mars especially, if you're talking about just going to Mars directly. How will the astronauts survive when they arrive there? We haven't tested out the habitat yet. The space station, if you look at it, it's still in the protected environment of the Van Allen belt of our Earth, right? The magnetic belt, magnetosphere of our Earth. Out there beyond the Van Allen belt, the radiation is extreme. We are here, we are protected to a certain extent, not completely, but within the magnetosphere, we are protected from that galactic and the cosmic radiation. But beyond that, on the moon and Mars, there is no such protection. And that is why we need to test out our habitats, our rovers that we will send with the astronauts, all the technology that they will need to live and survive on those on Mars. We need to test them out, and so we are going to use the moon as our test bed. It's a lunar test bed. We're going to prove our technologies here, and then we will prepare and send our astronauts fully prepared to Mars, so they will have a better chance at survivability, because Mars is a very hostile planet. It's saying, don't come here, I'm going to kill you, because 95% of the Martian atmosphere is carbon dioxide, right? It's really thin, only 1% of the Earth's atmosphere. That's how thin it is. It has a lot of galactic and cosmic radiation in addition to our solar radiation. So you can see it's really inhospitable. It's really a hostile environment for us to survive. And that is why we need to make sure we have everything working right before we send our astronauts to Mars and leave them there to die. We don't want to do that. And that is why we're going to use the moon as our test bed. We're going to test out all our technologies there, and then send our astronauts to Mars fully prepared. So that's what this talks about. The goal is to have boots on the moon by 2024. That's what NASA is working on right now, the Artemis missions. Artemis is, in Greek mythology, she's the sister of Apollo. We had Apollo missions, right, where we landed the first humans on the moon. Now with Artemis, we're going to land the first woman and the next man on the moon in 2024. And that is why this name, Artemis. So the first plan is, as a part of Artemis 1, we will have Orion orbit the moon and come back. It's going to be its test flight. The second is going to be humans. We will have 2 astronauts in the spacecraft. They will orbit the moon and come back. And then finally, as a part of Artemis 3, we will have the first woman and the next man land on the surface of the moon. So after these 2 test flights, then we will be ready to land it. So this shows what all we're going to send to the moon to test it out, so that it will help us go to Mars eventually. That is the plan for the Artemis missions. And then we are also going to build a station, a lunar gateway. This is what we're calling it. It's a lunar gateway, a little orbiting outpost around the moon, where Orion will come and dock, and then the astronauts will take the lander to the surface of the moon from this gateway. It's going to be an outpost for the astronauts to come, settle down, and then arrive to the surface. It will also have a lot of resources on board it. So yeah, we're designing the gateway as well. Today, there's a lot of work going on both Artemis missions and the lunar gateway. Now let's see the rocket. What is a rocket? The Space Launch System. It's going to be the biggest, most powerful rocket. It's in size-wise, it's almost the size of the Saturn V, but it's going to be more powerful because of its capacity. Orion will be sitting at the top here, and that's your rocket, the Space Launch System. Work is going on right now on the SLS as well. And when Orion launches, I think next fall, that's when we're going to launch Orion. When it launches, it's going to launch about the SLS. Orion's we did have a test flight in 2014 where Orion orbited the Earth and came back. So that was a successful test flight as well. But yeah, that's our rocket, and that's the spacecraft. Orion is capable of carrying 7 astronauts, but initially we are going to start with 2 and then 4. So 4 will be able to fit in there comfortably. But this is our spacecraft. So we saw the machines. Now what about the humans? There are a lot of physio-psychological challenges. We're preparing the machines, preparing the humans. What are the negative factors? Like I said in the beginning, human body hasn't been designed to live and survive in space, right? Why do we say that? There is no, the first biggest challenge our body faces in space is the exposure to extreme radiation that can instantly kill us. Lack of air, breathable air, can kill us instantly as well. But radiation is our biggest challenge because it can, if we are exposed to the solar and intergalactic radiation, then we are going to be exposed to a higher risk of cancer. So getting cancer and getting killed instantly, basically. So that's one of the challenges. Then there is zero gravity, right? While we're traveling for 6 to 7 months to Mars, we are exposed to zero gravity. What we've seen, astronauts have lived on the space station for 6 months and then more recently for a whole year also. And that is a part of how we're preparing to go live on Mars. So the neurovestibular imbalances, what does that mean is, here on Earth, we know we have a sense of direction. That's up, this is down, right? But in space, in the lack of gravity, we lose that sense of direction, orientation. And that happens because of this tiny little organ behind our ear. It's called the neurovestibular organ. So it gets disoriented, our brain is disoriented, we have no sense of direction. And so astronauts need about a couple of days to adapt to that new environment, to the zero gravity, when they go to the space station. There are also, like if something is kept in front of you, it might appear that it's further out or it's closer. So you can see how that can impact the tasks you're working on, right? And you would put people in danger, people around you in danger if you miscalculate, misjudge the distances, all that stuff. So they are given 2 days to adapt to the zero gravity. And then once, our human body is really good, it's flexible, it adapts. Once it adapts, then they can start working on heavy duty tasks, basically. So that's one challenge, the disorientation of the brain, plus the musculoskeletal system weakening. Here on Earth, look at our legs. They are the biggest bone and muscle in our body because they are working against gravity to help us move around, right? But in space, there is no gravity. So the legs are of no use. And the brain says, use it or lose it. So we start losing the bone in our leg, throughout our body, basically, but our leg muscles start getting weak as well. Bone and muscle atrophy is a big challenge. In 6 months, astronauts have lost as much as bone and muscle as older people when they get osteoporosis. So you can imagine what will happen in 3-year Mars mission. See, a Mars mission is going to be at least 2 to 3 years. They say 2 years, but I think it has to be 2 years. 3 years, because 6 to 7 months to arrive to Mars, 6 to 7 months to come back from Mars. That's 1 whole year, right? And then when you're going to live there, it's going to take you at least a year. You should be living there for at least a year to do some research, right? To be able to add some value after you've traveled all that far and spent millions of dollars. And then the third thing is, Mars and Earth have to be really close to each other when they're in their orbits around the sun, to save us time and fuel, right? That window when both are aligned really close to each other occurs every 2 years. So we have to wait for that window to launch, and to launch from Earth or from Mars, so that they can come back and forth between the 2 planets. When they are further away from each other, Mars travels really slower compared to the Earth. So they start falling, the distance starts increasing, they start drifting from each other, away from each other, and then it's really difficult for us to plan missions during that time because it's going to be really expensive. It will cost us fuel and time. So we don't want to do that, and that's why that we have to wait for that perfect 2-year window. So you can see a minimum Mars mission is going to be at least 3 years. And in these 3 years, if in 6 months astronauts have lost that much of bone and muscle on the space station, what will happen to their bodies in 3 years, right? Then there is the sleep disruption, the circadian rhythms of our body. Our body is used to this day-night cycle, right? We take everything on our Earth for granted, our atmosphere, our gravity, our day-night cycle. We don't understand its importance because we've been living with it, we've grown with it. But in space, that day-night cycle doesn't exist. So the sleep patterns are disrupted. And you all know, if we don't get enough sleep, what happens? Do we perform as efficiently? No. Our performance is impacted severely. And we can't have that happening, because if you're not able to focus, if you are not well rested, you can't perform well, then you expose yourself to a lot of hazards. You put yourself and other people around you in danger, right? So this is also a challenge. When you're traveling to Mars, you're going to be in an environment where there is no day-night cycle. Even when you arrive on Mars, it's going to be a very dimmer environment. The days are going to be really dim. Here we have a nice bright daylight, right? But on Mars, because it's further out, it's not as bright as we have on Earth. But even then we will have at least the day-night cycle. But when we are traveling, it's going to be a challenge. So how that affects the astronauts' performance, even on the space station today, for them to get a continuous 8-hour sleep is a challenge. And so what are the solutions? 4-hour naps as and when needed is what has been suggested. How effective that is, we don't know. It's an area of research. And then there's the psychological impact. You are away from your loved ones for that long. You are confined to a tin box. A spacecraft is basically a tin box. While traveling to Mars, you're confined to it. When you arrive on Mars also, you cannot just be in your t-shirt and your pants and step out, right? Because you will die instantly. It's a toxic environment. It's 95% carbon dioxide, plus it's a really thin atmosphere. So you will have to be in a spacesuit. You will have to live in habitats. So this is again confining you, and not everyone can survive in a confined space. So that's another challenge, and it starts affecting your psychology when you are to work like that. So these are some of the challenges, and there are also research areas. If they interest you, you should take them up. A few more slides. This talks about the difference about how human body, the male and female bodies, have been in space. The neurovestibular imbalances that I was talking about, body orientation, coordinated movements, and the perception is affected. And but yeah, like I said, our bodies adapt once we come back to gravity. So when they arrive on Mars, their bodies will adapt. They have to exercise for that long to keep their muscles stronger, right? The bone and muscles stronger. And so they have resistant devices up there that they use to work out. Penguin suits, drug supplements, but these are all temporary solutions. We need to find out if they are good enough for the longer duration. These for 6 to 7 months, we have to forget about those missions. Now we want to plan for longer duration missions, and we need to figure those out, the solutions out for long term. Yes, when on Mars we have 38% of Earth's gravity, but is that enough for our bodies, our bone and muscle to stay strong? We need to. That is also a research area. So hopefully on the moon we will be able to work on these research areas as well. Like I said, circadian rhythms and sleep. When I come from here to India, it's like 24 to 26, 30-hour journey, depending on how much of a transit time I have to, what flight I get and all that, right? But when I come there, it takes us adults to 2 to 3 days to adapt to the time difference, right? Because it's on the completely opposite side of the planet. So we are jet lagged heavily. We're waking up at odd times and sleeping at also it's the same. So that's how the impact is, and you can see what it will be. At least dynamics, right? Sometimes we will get tired of the similar kind of work routine, the monotony that will set in, not having your loved ones closer to you to talk to you. So those issues will arise as well. There will be cultural issues, people from different backgrounds. Um, some might, like for me, I grew up in India, so a few things that we are but sometimes people from different culture don't understand that. And when I've been on analogs, I've experienced this, and it comes as a shock to us. So adjusting to those kind of cultural issues will be a challenge as well. But when I've looked at it, for me, the bigger goal has been to get the mission done. So you have to adjust, you have to adapt, right, to the kind of people you are with, to understand where they are coming from, their cultural background as well, and then you adapt and adjust. And that's what will be needed of astronauts as well. Communication issues. There is a 15 to 20-minute delay from to come from a crew will have to be really autonomous. They will have to work by themselves. They will have to take important decisions by themselves. Today, the crew working on space station is all dependent on the Mission Control Center here in Houston. The Mission Control Center puts their schedules together. It tells them what to do. All the actions are controlled from here. There's no autonomy. So the crew will need to have that autonomy. And then there might be a possibility of communication issues between the Mission Control Center and the crew while they are working on their things there. And the mission control is 15 to 20 minutes signal away. The communication is going to be a challenge. So that can cause issues as well. So that's the psychological impact. Now, how are we going to work on these, find solutions for these? So we are taking it one step at a time. For the physical challenges, we are sending our astronauts to space for an entire year, like Scott Kelly and Mark Kelly. I'm sure you all know about it. In 2015, Scott and they spent a year on the space station. We had sent astronauts for 6 to 7 months, but we did not know how year-long. That's why that was the goal of this mission, to understand how it affects their bodies, their genetic structure, because the exposure to radiation impacts your body at the genetic level, at the DNA level. So it's really that and radiation. So yeah, we have sent Scott Kelly, and then recently Christina Koch was on the space station for a year. Now Chris Cassidy is on the space station for a year. So you see, we have been sending astronauts, but we can send them only one at a time. Send a lot of astronauts out. It becomes really expensive, right? It's not a possibility to send several astronauts. So we have to see data points. So that's not enough data for us to understand what's going on, but it's good enough to at least as a starting point to give us an idea. So we will keep doing this, and research is still going on. When astronaut Scott Kelly came back, and I was working at NASA Ames on the KEPLER mission at that time. So we all at NASA got to talk to him via a video call. And that's when he told us he had been up there for a year. It had been like 2 months since he had come back when we talked to him. And he said his skin, because of the radiation exposure, had become so sensitive. Even when he touched it, it turned red, and it burned. It gave him a burning sensation. That's how radiation can damage your skin. It can cause an impact. His possibility of getting cancer is really high right now. And then his body was still trying to adapt to the Earth's gravity. He got disoriented abruptly sometimes, even in these after 2 years, and he would just collapse. And so you can see how challenging it is for our bodies when they come back from space. And That's why we are doing these studies. We're sending the astronauts and trying to understand. But every human body also reacts differently. That's another important thing we need to understand. Like, for example, I've been on high G flights, right? I've been on low G flights as well, but I've not gotten nauseous to the point where I've thrown up. But there are my counterparts who have that environment differently, and we need to take that into consideration also. Now we saw what we do to understand the physical impact, but to understand the psychological impact, we don't have to wait to send people to space and then understand it. Here on the surface, analog astronauts, we call them, we call us analog astronauts, who are similar to astronauts who are qualified enough to be analog astronauts, and we can put them in habitats like this, lock them down in the habitats, and understand how basically we'll be guinea pigs, right? Put them in the habitats and see how they're working together for long durations. So these are some examples of analogs here. Nemo is off the Florida coast at the Aquarius Reef. It's an underground sea, underwater. That's 2-month missions they've been doing there. Arctic Research Station is similar to the Mars Desert Research Station that's in Utah, but it's an extreme environment. So these are all in almost extreme environment, similar to what we might have on Mars. They say the Antarctica and the Arctic is almost similar to Mars, but Mars is even extreme than both Antarctic and Arctic stations. So that's the Arctic Research Station. This is MDRS, Mars Desert Research Station, very Mars-like landscape. That's in Utah, here in the US. And this is HERA, Human Exploration Research Analog, here at Johnson Space Center. There is a habitat in a big building. That's where I was a commander for both of these missions. The HERA mission in 2015, and I was selected a commander for the Mars analog at the Mars Desert Research Station as well. So a little bit about HERA. HERA is Human Exploration and Research Analog. Basically an analog mission to understand how we will survive in what is the psychological impact. So we were 4 of us, 14 days we were locked down in the habitat, completely disconnected. Our goal was to travel to geographers. In reality, it will be a 729-day mission, if I remember the number correctly, but it was all those 729 days were compressed into a 14-day mission. Yeah, we got to design our mission patch. That's when I went for the medical and psychological evaluation here at JSC. I was working at NASA Ames in California at that time, so I had to come down here to JSC for the physical and medical and the psychological exam. That's us in the habitat before we started our mission. That's the 4 of us. I'm the commander. Samuel Wald is the flight engineer. Mission specialist 1 is Samson Fan, and Deborah Hodges is mission specialist 2. That's inside the habitat. Lower level, this one is. This is the medical science station behind me, comm station, no internet, no Wi-Fi, nothing. Our connection with the world was only through Mission Control Center. They would give us the news updates, and we would get a news update every day to see what's going on planet Earth. And yeah, they would look at us, control our schedules, tell us what to do. There were cameras also in the work areas. So we were basically guinea pigs on a mission. This is the ladder that was our only way to travel up and down between the 2 levels. So I must have gone down like 100 to 200 times on this during one day. We got to eat same food like astronauts do on the space station, completely dehydrated. We have to hydrate it. There's a way to prepare those meals so you can eat them. We were a part of a lot of research going on, and we had to perform a lot of tests, fill out a lot of surveys, get blood drawn, do ultrasounds. We were taught to do ultrasounds on our heart as well. So a lot of training. These are just a few pictures. I'm wearing a dosimeter here with the yellow strap. It's attached to me, the black and red device. It measures the amount of white noise I was exposed to for 24 hours. And then they want to understand how that exposure to the white noise affects my performance, right? Each of us had to wear it for 24 hours. You know what white noise is, right? And a spacecraft is the biggest machine ever. So it is going to make a lot of white noise. We were told we were exposed to only 10% of the white noise that astronauts are exposed to on the space station. So it starts to affect your performance sometimes. I get bored continuously listening to the white noise. And when we travel to India, like I said, we travel in these big airplanes, the jumbo jets, and you have that constant sound of the, it becomes bothersome. And that is also responsible for the performance, psychological impact. It's a psychological impact that happens on your brain. And that's why they want to understand the amount of white noise you're exposed to. We had to perform exercises as well. That's our workstation on the upper level, and that's the kitchen behind me here. So that's the upper level, and in one corner of the upper level, we had the exercising equipment. It's a very small space, 900 square feet overall. So, but it was good enough for, that's how a spacecraft is going to be basically. That's our comm station on the upper level. That's the airlock. We got to, if we needed some privacy to do our family calls, our medical calls, our psychologist evaluations, we would do it from here. That's the crew quarter. I think it's a big enough space to spend my 8 hours for sleeping in the night. And then, yeah, we had to perform experiments, like I said. So I'm planting gel seeds in a nutritional gel to see if plants will grow. The plants did grow. They grew quite big by the time our mission was over, about, I would say, 2 feet long. That's how long they grew. Here we are simulating that there is a solar flare that erupted. The level of gone high. There was an accident there. The level of toxic gases has gone high. So we're wearing the masks and sheltering in the airlock because that's the heavily sheltered area, the most heavily sheltered area on the spacecraft. I am studying a sample of an asteroid under this special microscope. It has light at the bottom. So we're going to an asteroid, right? So we were trained on how to identify mineral content in the samples of that asteroid. Here we simulate that the commander fell down, broke her arm, and the crew is fixing her arm. We built rovers, tested them out. Here I'm flying the flight simulator over the surface of the asteroid, measuring the temperature of the air coming from that vent in the spacecraft, using the infrared thermometer because it was a part of systems maintenance, spacecraft maintenance on the mission. And that was how the mission was completed. We also had to do a lot of other studies that I haven't included because there's so much to talk about, and then my presentation gets very long. But yeah, for 40 hours, we were sleep deprived. We were not allowed to sleep. We were navigating, and when you're navigating, you won't be sleeping, right, through an asteroid storm. So they just wanted to test the impact. Will affect us. There were a lot of, so there was blood drawn. We were not allowed to eat even. It was fasting. We were fasting. We won't have time to eat when we're navigating through an asteroid storm. So yeah, there were a lot of studies like this, but I just wanted to give you guys an overview. And then that's Mars Desert Research Station. This was more like we had Mission Control Center telling us what to do on the Hera. Here there was no one to tell us what to do. This was a mission that we ran ourselves. But the good part about this was the Mars-like landscapes and the EVAs that we got to do. On Hera, we did not get to do EVAs. Here we got to do extravehicular activities, put on the suit and go explore for 3 to 4 hours. And physically, it was really draining and exhausting, but I learned how it made me stronger. I really enjoyed those EVAs. They were challenging, but that's what I like. A lot as well. We had some research goals that we had set for ourselves. But yeah, several students from India have come to the Mars Desert Research Station to work on these analogs. So yeah, you guys, if you're interested, you can put a mission together, but you need to have good research goals. Like if you won't have any research goal and it's not going to add value, it's just a waste of your money, right? So if you want to come, plan it out. You have to apply, you have to put in some dollar amount when you apply, and then you come here. This was a part of one of my projects that I was working on. That's how I got to be on this mission as well. I'm trained as a scientist astronaut candidate for Project Possum, Polar Suborbital Science in the Upper Mesosphere. It's to study the noctilucent clouds that we've been observing in our polar regions. They're only in the polar regions, and they're in the upper mesosphere where there should be no clouds at all. And they're not like our regular clouds. They're slightly different. They shine, they have a glow when the sun's rays fall on them. So to study those clouds, we will have to travel to the upper mesosphere. When we travel to upper mesosphere, there's no gravity there, right? And that's why we have to train to work and perform in zero gravity. And that was the goal of the training. So I was trained. After I trained, I got missions as a scientist astronaut candidate to test the performance of the suit, to perform different science research. So yeah, that's been something I've been doing on my own time, apart from my full-time work as at NASA. This is not related to my work. Let me clarify. Commercial suborbital spaceflight research program. And that's during our training, we got trained in hypoxia, lack of oxygen or oxygen deprivation, how to recognize the symptoms of that. This is the first suit that Final Frontier designed, the commercial company created. And first, when I flew the research missions, I flew to test the performance of this spacesuit. And suit is there. This is during the training when I trained in the Super Decathlon and the Extra 300 aircrafts for high Gs. When you pull high Gs, what happens? High Gs meaning what? Here on Earth, we experience 1 G gravitational force, right? But when you're flying, when you orient the aircraft in certain directions, you will pull a lot of Gs. You will experience twice the G, 6 Gs in a centrifuge. And astronauts, when they launch into space, they pull up to 4 Gs. So it depends on the spacecraft that you're going to travel in. So every spacecraft will have force when you launch. What happens when you pull Gs is your blood is getting pulled away from your brain, and then your brain is going to eventually be deprived of oxygen, because when the blood gets pulled away, it doesn't get any oxygen, and then you might pass out. And if you don't fix that situation immediately, you might die. And that's what happens when you pull Gs. In zero gravity, it's the opposite. I forgot to mention that when I was talking about the zero gravity physiological effect. All the blood, all the body fluids are rushing up because there is no gravity to pull it down and keep it balanced throughout your body. They're all rushing on the brain. The astronauts, their faces get really puffy in zero gravity because all the body fluids are traveling up towards the face. They lose their vision as well because of the pressure the fluids are putting on your eyeballs. Eyeballs get swished. They don't lose their vision completely, but to a certain extent, they lose their vision. When they come back, their eyes adapt and they might regain most of their vision, but not fully. That's what I've read. That's what happens to us, has happened to astronauts who have come back after 6 to 7 months on the space station. But this pressure that the body fluids cause on our brain is called intracranial pressure. And there was a study I read about last year also. It affects one of our biggest nerves that connect to our brain. And there's research going on that as well. You're in zero ground, but yeah, it's a little bit of a challenge. But high gravity, which you're exposed to only during launch, is one of the biggest challenges. So we are trained to understand how to handle our bodies in the zero G and high G environment. Here I am inside the aircraft, the Falcon 20 aircraft that me standing in front of before. This is the modified aircraft where we fly our research flights in. It flies parabolas. You all know what a shape of parabola is, right? So we fly parabolas to simulate zero gravity. When you are climbing on the side of the parabola, you are pulling a lot of G's. When the parabola reaches at the top, then you're floating, you get the zero gravity. And then it dives down again, and you are again pulling G's. So that small window of 20 to 23 seconds where you get that zero gravity, that's when we are performing these tasks that are assigned to us to test out the suit. Here this is a task-free parabola, so I was just having fun trying to roll on my side. This is in the blue suit, I'm performing deadlifts in zero gravity exercise. I'm testing a version of the hexoskin called the astroskin, which is like a vest. You wear it, and it measures all your vitals when you are performing tasks. So the Canadian Space Agency designed a customized version of the hexoskin. It's called the astroskin. We wanted to test it out, and that's why I was wearing it inside the suit and performing exercises. So these are the kind of research missions I've flown. This is another research mission flying in this Mooney aircraft above 18,000 feet. So I have to wear the mask. We were trained in how to use that and put it on when you need it. And then, yeah, these are the noctilucent clouds in the lower slide here. Very few of them that day. After we left, the next crew came in and they got to see a lot of noctilucent clouds. But we got lucky, we got to see auroras as well. So we studied the clouds as well as the auroras. So that's awesome. And then I've also done a land and sea survival training, a spacecraft emergency egress training. I never grew up as a swimmer. In India, swimming was not a common thing at that time. So it was challenging for me. I became a swimmer when I came here. But even then, when I started my scuba lessons, it was a really scary feeling. That is the first time I discovered I had a fear of being under the water, even though I had a regulator in my mouth to breathe the air. First time I was really scared of something, but I overcame that fear. I went back next day, calmed myself down, told myself I have to do this, and I successfully completed the scuba lessons. In this video, we are simulating a spacecraft emergency, underwater spacecraft emergency. Okay, so our spacecraft has dived into crashed into the water. I'm wearing glasses that's completely blocking my view. I'm blind basically with these glasses that I'm wearing on my eyes. So we are simulating the dark. It's crashed in the night, and I have to get out of my seat belt, and I have to find the exit and come out. And that's what we're doing here. I have a bottle of air in my hand. If I need to breathe the air. I found the exit, and I'm coming out. So being in the water was a little challenging and doing that, but I went back again and did it a couple of more times. So it's fun when you get to challenge yourself, and when you overcome your fear, it really feels fulfilling. So when I overcame my fear of water, it really was satisfying to me. So that's another message I want to share with you. If you have some fear, challenge yourself and overcome it. There's nothing that you can not do or not overcome. Okay, it's a really fulfilling feeling when you accomplish that, when you overcome that fear. Here, this is the centrifuge I was talking about. It was a research study done by the FAA, which is the Federal Aviation Administration here. Why isn't this working? Okay, so I'm in a centrifuge. The FAA wants to understand now with the new spacecrafts we have, the Virgin Galactic's Spaceship One, SpaceX, Dragon, X-Cors, Lynx. They want to understand, and tourists will start flying on. Should we train tourists to understand how Gs work, or should we just put them in the spacecraft and launch them? They wanted to understand that, and that is why I was a test subject in this. I've pulled up to 6 Gs in the centrifuge. You will see it here. There were 2 flight profiles that I flew. One was of Spaceship One, Virgin Galactic's Spaceship One, and the other was X-Cors Lynx. So in one of them, I pulled 6 Gs. But my input to them after this study was, yes, you should train tourists if you're going to put them in a spacecraft and launch them into space. Because when you pull Gs, everyone's body reacts differently. Everyone's reaction is going to be different. Not everyone is going to be able to handle it. It comes as a shock. Your cheeks are getting pulled, your skin is getting pulled, everything, your bone, not your bones, sorry, your muscles on your arms and your legs are getting pulled. It's not a very comfortable feeling, and you feel disoriented as well. So you have to stay focused in one area. So people might get into a state of shock. They might get violent even. So you don't want to be flying with someone who is not trained and who might get violent, right? So we do need to give some sort of training uh, to tourists so that they know what to expect and they don't go in a state of shock when they pull the G's. Okay, that was the goal of there. It's at 6G now, the max GR. So I'm still standing. I haven't fallen down. I found out during all this training and this study, during the possum training and this study, that I can handle G's pretty well. My body can handle the G's pretty well. I don't get nauseous if I follow the training routine that I've been trained in, all the exercises that we're trained in, Hicks maneuver and all that stuff. I'm still standing. So yeah, can handle the G's well. It's just a matter of staying focused and doing what you've been trained in. Okay, that was a long one, but I think almost, yeah, not. I didn't go 2 hours at least. We started off late as well, but yeah, hope it was interesting. You got to learn a lot, and this is me on social media. You can connect with me. I will answer your questions, but I won't be able to answer specific questions like if you say I have this degree and that degree and now I want to do this, what can I do? I get a lot of those questions, but I'm telling you, I really do not have the bandwidth to address every individual situation or every individual specific requirements that you have. But I do my best to get back to you. If there are unique questions, I'll definitely get back to you. I have a website. I haven't included that here, animapatilsable.com. Where you can go. I have a frequently asked questions section. You can look at that. You will find answers to most of your questions. But yeah, do send me messages. Do connect with me. As and when I get time, I will definitely reply. As you see, I'm extremely busy doing a lot of things. Plus, I have 2 boys, and I'm involved in their scouting and their studies and everything. So it gets really challenging to find time. But I do manage, and I do get back to you as and when possible. So yeah, thank you. Thank you for listening. Hope I didn't put you all to sleep.
No, ma'am. Thank you so much. It was really informative and insightful. Your speech was incredibly explanatory and inspiring. I must say, your journey is no ordinary. Your experiences are stunning and so diverse, ma'am.
Thank you. Thank you. Appreciate it.
Would you like to answer some questions? Like, there's one in the chat box.
Sure, we can take a couple of questions.
Okay. So, Amarnath asks, like, manned space travel beyond Earth's magnetosphere is dangerous, especially during greater sunspot cycle. So, with which new spacesuit materials is NASA performing research to reduce effects of solar and cosmic radiation?
So I don't remember off the top of my head the specific spacesuit material, but yes, NASA is taking that into consideration as well. But remember, our sun is not in a very super active stage where we have flares coming out or sunspot cycles happening very often. And NASA has its own solar observatories, right? And the telescopes we've launched that are studying the sun's activity all the time. So we will always be observing that. And when we send astronauts to the moon and Mars also, we'll be planning their EVAs according to what we are seeing the sun's activity is. So yeah, even if you make the suit out of the toughest material, it is really important to know that if something like this happens, we are still going to expose our astronauts, and this how sturdier will a spacesuit be to protect them. So rather than relying on the spacesuit alone, we will have a lot of factors involved, like studying the sun and its activity, the solar activity that's going on. Having underground habitats is also one of the ideas that we are exploring, because if you're underground, then we are not exposed to the radiation as much. And if we see there is a heightened solar activity, then astronauts can take shelter in their underground habitats until the activity has gone down, and then they can resume their extravehicular activities. But yeah, good question. The materials, I'm not a a materials engineer or a chemical engineer, so I won't remember the names. But yeah, last year when I was working on the spacesuit, I did get to look into what the material was. I just don't remember it off the top of my head.
Thank you. There's one more question.
Mm-hmm.
Has NASA considered hibernation CRO for humans to use during interstellar travel?
Yeah, the cryo. Yeah. So yeah, it's see what we see in the movies. You're right. This is such a simple solution, right? It would, if it would be possible practically, but it's still a theory. It's still fiction. Hibernation. We haven't tested it out yet. Not NASA is not working in this area, but I'm sure there are other private companies or private research firms that might be working on the hibernation technologies. NASA isn't looking into it right now. See, our focus, NASA has to limit its focus at times because of the funding, right? It's a government organization after all. So depending on what funds we get, we have to focus on that. And we put out proposals, and those proposals get approved, and only those get funded. So right now, NASA's focus is the Artemis missions, going to the moon and developing technologies for living and surviving on the moon. So hibernation will come into picture when we are traveling beyond our solar system, right? Beyond Mars. For Mars missions right now, we don't need it right now. But yeah, so that is not a priority at NASA right now.
One more last question.
Yeah.
So the time delay between Earth and Mars is 20 minutes. Is it possible to make the transmission of information and data between the planets quicker?
Yeah, like I said, again, it will depend on if we can implement such a technology, right? Other than bringing the planets closer together, I don't see that happening sooner, because see, the deep space network, yeah, I don't know how many of you have heard about it. That's our only way right now to communicate with our spacecrafts. Even Voyagers, which have gone into the interstellar system now, beyond our solar system, into the interstellar space, I mean, even with them, we are communicating through the deep space network. So deep space network is the only one we are relying on for communication with spacecrafts that are on the moon, Mars, or beyond in the solar system, anywhere in the solar system or beyond. So with whatever bandwidth we use today, that's not a possibility. But yeah, you're right. The technology is improving, and if we have a newer solution, I'm sure we will implement it. If you guys have ideas, go to the NASA website. NASA is always looking for new ideas, proposals. Do some research. Even if you Google, how do I submit a NASA proposal? How do I submit my idea? Go ahead and do that, and you will definitely find a way to be able to contribute. Also explore the Deep Space Network website. They might be receptive to ideas as well.
Thank you, ma'am.